Python recursions are used in functions to call the same function that you have defined. This can be applied in writing complex codes where you just simply write a recursion function and the function can keep on calling itself recursively until you achieve what you want to achieve. But there are disadvantages as well as you have advantages. And one of the major disadvantages would be that if you write a recursion function, if that function does not have a definite ending point, it is likely to run infinitely. So if you have infinite loops, and keep in mind that whenever you're running a program on your system, you're using your memory, okay? So if you're running a program that just keeps on running again and again and again, you're likely to crash that particular program. In today's video, we'll be talking about Python recursion functions and just give little examples to back up. Stick around. Now, back again, we've gone back to our previous Jupyter notebook where we were already working on our Python functions. Now, I'm going to define a basic recursion function. Now, we can just say def. Let's call it recur, just a function. In this function, let me just write a little block of code. And let me say print n, okay? So whatever n is, let it be the same parameter that will be defined here. And so if we're going to do that, let me write an if statement. If n is equal to 0, what should it do? Let it print something, okay? Let it print maybe, let me just so what I'm saying here is that if n, the value of that parameter, is equal to 0, let it print this particular statement, end of recursion. But what about before the value actually becomes 0? What is going to happen before then? Let me see here. Else if, so we're saying if n is equals to 0, run these codes. Else if n is let's say greater than 0, now we're going to take the same function, okay, and apply it here. If n is greater than 0, let it keep running the same function, but in this case the parameter here will be n minus 1. So what we're trying to do here is, if we declare a value of n, for example, let me just call out this function, recur. Let's say n is 5. Let me just give an attribute of 5. If I run this code, as you can see here, when n was, first of all, you've declared the parameter, the attribute as 5. So when n is 5, print the value of n. So it will print 5. Okay. Now it will check, it will run it across these conditions. N is equal to 0, which is not, return 0. If n is greater than 0, run the same function again, which is n minus 1. So what that simply means that it will run a recur function of n into 4, because n minus 1 is 5 minus 1, which is 4. So it will now run it as 4. 4 here will print 4 here, because it will go back again and print 4 here. It will run the same thing. 4 minus 1 will become 3. When 3 comes back to the top here to print 3, it will come here again. 3 minus 1 will be 2. When you go back to the beginning, it will print 2. Then here it will come back to 2 minus 1, which is 1. Come here to print 1. Then 1 minus 1, which is 0. When it comes here now, back to the top, if n is equal to that 0, it will print end of recursion. So I actually put a new line here. It's not compulsory. So if you want to bring that closer, it's not compulsory. So that is a basic example of a recursion function. But also keep in mind that the way you arrange your code matters a great deal. Now, this same program we just written, let me write the same thing again. I've just copied and pasted the same exact stuff. Let me rearrange it just so we look at it from another perspective, okay? Now, I've taken the print and I've put it down here. And let us see what will happen. Now, before I run this code, let's get a basic understanding here. If we are declaring recur, the attribute here is 5, right? We're running this function, we're calling the function. You will see that here, there is no print anymore, right? So if n is equal to 0, which is not, print end of recursion. So this might not run now. Else, if n is greater than 1, if n is greater than 0, run this, right, before the print. So you would notice something. Before the value gets to the first print, it has run this same function again before it gets to the same print. Okay, so it will keep on going the same way before the print. And what that simply means is that it will be printing the values in reverse because the print is coming before this function. So if you run it, you will see that it prints everything but in reverse. Okay, so you can see that the ordering of your code matters a great deal. Let me rewrite this same code again, but this time around, instead of making the print here, let me take the print and put it before the function is, before the recursion function is called, okay? Because this one here is the main function, and this recur n-1 is the recursive function, okay? And this part of it is what we call the break part, because in your recursion function, there should be a breaker. If there's no breaker, it will keep on running infinitely. So our breaker here is n equal to 0. So when it gets to 0, it stops, it terminates the program, okay? So now, from here, because I've put the print to come before the n-1, if I declare n as 5, it's going to print the value of 5 first before it runs this one. So when we run this, you see that it will run in a forward measure compared to this previous code, which ran the same way, but it had to run backwards. Another use case of function, just as several use cases, we can also use it in areas of maybe like writing a Fibonacci series code. First of all, what is the Fibonacci series? Fibonacci series is a mathematical method that is applied with numbers, such that if you have two numbers, if you want to predict the third number will be the addition of the last two numbers. Okay, the fourth number will be the addition of the second and third number. The fifth number will be the addition of the third and fourth number, and so on and so forth. Okay, so now I'm going to write a code. I'm just going to write a regular loop, and I'll write the same code in using a recursion. Fibonacci series. Okay, now in this Fibonacci series, let me create a list. Okay, in this list, the values there are 0 and 1. So we want to use Fibonacci series now to predict or to calculate the remaining values or the values that will follow. Okay, and if we're writing this function, we don't want it to run infinitely. We want it to stop at a certain point. Okay, so how do we do this? Using a while loop. We can just simply say, while the length, let's think this through now. This list you're seeing here has a length. Okay, so let's first take the length of the list. Now the length of that list is currently 2. Okay. If the length is less than or equal to 10, now I am just using 10. It can be 15 or any number, but we just don't want it to run infinitely. Okay, so while this is this, let us think about something here. The actual code we want to run, the Fibonacci code now, is supposed to add the previous two numbers, correct? And if this is the case, we can just simplify it by saying length of list length of list minus 2. Now, the length of list minus 2 is what will give you, okay, no, first of all, let me even put this here, list, because here we are actually calling out the index number, okay? So we're trying to call out the index number here. And the index number here is like saying lists of 0, okay? But how do we get 0? 0 will have to be the total number, which is 2, minus 2, because we're trying to get the last 2, okay? So what will be here will be length of the list minus 2, okay? Let us now add it to the same thing, length of list here. But instead, we'll use minus 1, Okay, so this one here, length of this list here is going to, okay, let me just do something here, just for better understanding. Let me take this here and run length of lists. So you see length of list is 2. Okay, so everything here is what you are seeing here. So this is just like saying 2 minus 1. And 2 minus 1 is like saying 1. Okay, and that means you are saying the list with an index of 1. Okay, the same way list with an index of 0. In this case here, it will be 2 minus 2, which is 0. So it will be list into 0. The index is 0. Okay, so that's the idea behind what we are doing. Now, this value you're seeing here is the actual value that calculates the next Fibonacci number. Okay, now let us store it into a variable and call the variable x. So x is equals to the next Fibonacci number. Okay, now what do we do? Let us append it. We are appending that same value of x into the original list. So whatever it is we calculate here as the current Fibonacci value, we'll add it to this list value by appending it. Okay, now that is for that. Else, what should happen? So we've said while the length of this is less than 15, you should keep on running this code, keep on calculating the Fibonacci numbers, and keep on appending it to the list. Okay, else what should happen? What should happen? Let us just run a little print statement of loop. We can also just print out the actual list. Oh, so we can print out the actual list, which is LIS. If we run, where is that error there? Oh, indentation error. All right, so if you print that, you get the full sequence. Now, the reason why it had to stop at 610 is because the total length of this is now 15. And when it calculates the length to be 15, or rather, when the length is not less than or equal to 15, it terminates the program. Now, this is writing the Fibonacci with a loop, okay? Let's write the same thing using a recursion. Now, I'm going to still have to borrow, I'm going to have to borrow some of my code here, okay? Let me see, let me use this one with loop. But this time around, I'm going to do the same thing with recursion. It's not so different, it's just a little similar, just a little difference, something's going to have to observe. Now, in this case, we're still going to be using the same list, which is 0 and 1. In this case now, we're going to define a function. Let's call the function recurve, and let us have that parameter as x, okay? Now, let's run an if statement, okay? If the length of list is less than or equals to 50, it can be anything. I'm just using 15 or 10 or whatever it is. Just use the total amount you want, okay? It's just my own example. What should happen here is if the length of the list is less than or equal to 15, it should keep on running that same code, okay? And when it runs the Fibonacci code, it should now run the recursion function again. So in this case, the recursion function is this. But for good measure, let's deduct 1 from that. And else, just print the list. I'm just trying to keep it simple. So let me take all this out. Okay. So let's go over our codes again. We've defined our list. We've defined the recursion function. And we are saying that if the length of this is less than 15, run this Fibonacci code. So this whole stuff you have here, we can just say list.append, so that we can actually append the values into this list. Otherwise, it doesn't make any sense, okay? So we've appended it, and once we append it, we run the same recursion function again, else print the list. So, okay, yeah, I need to actually call out the function. I ran it the other time, but I didn't call it out, so I need to call it out. Let me just give it any value. So here we go. We've run the same thing with a while loop, and we've run the same thing with a recursion function. Now, let's look at another example. If we're going to be running a factorial, of course, a factorial would be, if you say what's the factorial of 6, or maybe factorial of 3, you can use an example of 3. Factorial of 3 will be 3 multiplied by 2 multiplied by 1. Okay, factorial of 3, okay? But what if we had more complex examples? So, but let's just write something to define a factorial. Forgive my spelling, it's just an example. Define the factorial function. So let's now write if x or z or whatever. Oh no, let me use x because we should have the same thing here. If x is equals to 1, let's see, return 1. Return 1. Okay. Else, return x multiplied by, no, let me do the same thing. Let me just copy it so I don't make any errors, okay. Factorial, but here I use x minus 1. So what we are doing here is, we define our function to be factory. It doesn't make sense. Let me just write it, factorial, okay. Let's write something that would make sense. Factorial, okay. Okay, so let me explain this now. So when we write the function called factorial, the parameter here is x. So we are saying if x is equal to 1, return 1. Okay? But if it is not equal to 1, what should it do? It should return x multiplied by factorial of x minus 1. Now, what is the factorial of x minus 1? Let's assume x is 4. It simply means you are saying 4 multiplied by factorial of 4 minus 1. Okay? And if that is the case, the function will still run itself again. And it will now be converted to 4. Just follow me, guys. 4 multiplied by 3 multiplied by factorial of 2. Or rather, of 3 minus 1. Okay? And if this is the case, it will still be broken down further into x multiplied 4 multiplied by 2 multiplied by factorial of 2 minus 1. You see it now. And if this is the case, it will still be saying 4 multiplied by 2 multiplied by 1. Okay? Multiplied by 1. So that's exactly what you're going to get there. And when you run that, you get 24 as your answer. But if you come back here, when x is equals to 1, according to our code here, we've said that if x is equals to 1, it should return 1. So now that x is equals to 1 here, the code is going to terminate. So that's why I didn't wait for it to get to 0. Because if we want it to get to 0, if we multiply 0 by everything, the factorial will be 0, which is wrong. Okay, so we stop at 1. That's just mathematical stuff. Okay, so let's run this now. So you can see the factorial here is 4. Now, as we've already discussed, when you're running a Python recursion function, the recursion function is likely to run infinitely if it doesn't have a break point. And for this reason, the system will crash. So to prevent the system from crashing, Python has an inbuilt recursion limit. To find out your recursion limit, you can just, the way you do that, you just say, let's import, or no, let's say from sys module, import get recursion. Am I spelling this correctly? Get recursion limits. So here, if we should create an object of this class. So our current recursion limit is 1000. This simply means that your script will run for 1000 times, and then at the 1001st time is going to break as an error. Let me try to run something here. For this factorial value, let me run 1500 and let's see what's likely to happen. Now it's going to give you an error because the maximum recursion depth has been exceeded. Okay, but if you want to adjust this, you can also say from system, I'm just trying to copy and paste so it will be faster. You can use set recursion limit instead. So if you set the recursion limit, you can create an object of that class. Let's set it to 2000 and run it. Okay, if you set it to 2000, you can run this again, and you see that the new recursion limit will be 2000. Okay, now let's go back here and run this code. So you see that it can calculate your factorial now because your recursion limit has been exceeded to 2000. So that's it for today's video. I hope you learned one or two things. Don't forget to subscribe to this channel if you have not already subscribed. It lets us know that you appreciate what we are doing. Hit the like button and comment on your observations or questions, and let's work on something good together. Until our next video, bye.